How are you? So today we are going to check on the integrated science on the topic of force and energy, the substrand on the what? Determining the pressure. So maybe we shall start with the background of it. What is a pressure class? What is a pressure? One, what is a pressure? Nani Hafsa? Yes, what is the pressure? Malik? Raise your voice. So when you talk about the pressure, you are talking about the force that acts perpendicularly per unit area. So pressure is a force that acts perpendicularly per unit area. From that statement, a pressure has two hints there, a force and per unit area, as one of the main statements that are going to help us in determining the what? The pressure. So the first thing when you are determining the pressure, you talk about it's the force that acts perpendicularly per unit square. So remember, there's this force and there's a per unit square. The area within, when you're talking about the per unit square, you're determining the what? The area of it. So when you're determining about the pressure, an examiner can ask you to drive the what? Examiner can ask you to drive the pressure. And how do you determine it? You determine the pressure. Under determination of the pressure, there's a what? There's a force that you are talking about, and there's a what? There's an area. That's what they're talking about. It's a force that acts perpendicularly per unit square. It's a force that acts perpendicularly per unit square. So when you're determining it now, so when you're driving it first, SI unit for force is what? SI unit for force. Force is measured in what? Force is measured in what? Yes, force is measured in what? In Newton. Area is measured in? Area is measured in what? In meters? The meter square. Now, let's check on about it. There's SI unit for what? Newton. Newton is written as what? Newton is written as what? As N. While areas is in meters what? Square. So which is going to develop to what? Newton per meter square. So when you're determining the force, you should be the pressure, you should be able to know that it's going to be determined in the Newton per meter square. So at the same time, the reason why we are learning pressure, we are learning pressure for us to be able to know how they help us in our day-to-day activities. Like, we have two comparisons when you're determining the pressures. You have two comparisons when you're determining the pressure. Remember, when you're talking about the pressure, a pressure shall be determined by the surface area. Pressure is going to be determined by the surface area. And we said when the surface area is large, what is going to happen on the pressure? When the surface area is large, what is going to happen on the pressure? When the surface area is large, what is going to happen on pressure? Asha? When the surface area is large, what is going to happen on the pressure? The pressure will do what? The pressure is going to decrease. What if when the surface is small? The pressure is going to increase. When you look on these two boxes here, when you look on these two boxes, you have box A and box B. The box A on the right hand and the box B on the left hand. So when you compare the surface of the two, which one has a large surface? Which one has a large surface? Box A. And the box B has less surface. So when you compare the two of them, which one now will be able to generate more pressure? Between box A and box B. Which was going to generate more pressure? Box B. Why are you saying box B? Why are you saying box B and not box A? Because of what? Because of what? Because of the surface area. So the surface of box A is less compared to the surface of box B. The same knowledge is going to be driven back to the what? To the day-to-day uses. And that's why we find now the knife that is so blunt and the knife of that it's sharp, they'll be able to work in different manner. The knife that is so sharp has less what? Surface area. The knife that is sharp has less surface area compared to the knife that is as what? It's blunt. And that's why the knife that is so sharp is easier for you to be able to use in what? In a day, in cutting, compared to the knife that is so blunt. Because on that blinding, the surface of it is large. Now, today you are to determine how to get the what? How to get the surface, the pressure of it when you are given such a question. Like, here you have an illustration of a question where they're talking about a rectangular block has a length of 15 centimeter, a width of 6 centimeter, and a thickness of what? 4 centimeter. And the mass of what? The mass of 800 what? Kgs. 800 kgs on the block. 1,800. So the first of all, we try to check on the what? The shape that they're trying to talk about. Is a rectangle already? Is a rectangular block. Under this rectangular block, we should be able to determine the length, the width, and the height. So under our length, they're talking about the length to be what? The length to be what, class? 15 centimeter. Then the width to be what? 6 centimeter, and the thickness of what? 4 centimeter. So remember, the baseline of pressure works upon the what? The SI unit. The baseline of the pressure works upon the SI unit. You have to remember that each working, the rule should be it to be under the SI unit. Like here now, when you're coming to determine the what? The pressure of this one. When you're coming to determine the pressure of this box, you can realize, you can see it is in centimeters. You can see it is in centimeters, isn't it? So let's check on the first question. What is the weight of the block? What is the weight of the block? What is the weight of the block? So you should be able to understand. When they're asking you to look for the weight of the block, first of all, you should be able to know what are the functions, what is the formula for you to be able to get the weight of the block. So now, as a learner, you should be able to know the weight. How do you get the weight, class? What is the formula of getting the weight of the block, class? Yes? Mass, good. Mass times what? Mass times what? Gravitational force. Gravitational? Mass times gravitational force. So you determine here. Remember, this mass, class, remember this mass. The mass should be in what, class? The mass should be in what? The mass should be in kgs, class. Always check on your mass. Mass given it is in gram, convert that gram into what? Kilograms. If you have been given mass into grams, convert those grams into kilograms. Like here, when you check on our question, the mass of the block is what? The mass of the block is what, class? 1,800 grams. So we convert this 1,800 into what? Into what, class? So we know very well. 1 kilogram is equivalent to how many grams? 1,000. So what about the what? 18 grams. The question mark. So you take 18 grams. 1 kilogram over what? 1,000. So grams will cancel grams. 1, 2, then 1, 0 will bring that. So having our what? As kilogram. So you can see now, already now we have our mass. We have our mass in what? In the kilogram. You have mass in a kilogram now. So what do you do now? Our formula said when you're getting the weight, you take the mass, you multiply by gravitational pull. Class, what is a gravitational pull comprised of how many units? One gravitational pull is equal to 10 Newton per. Yes, so we come in here, we multiply by 10 Newton per the kilogram. So you realize the kilogram will cancel the kilogram. So the 10 will remove one decimal place. Having our answers what? 18 what? 18 Newton. So from now you realize the first question, what is the weight of the block? The weight of the block becomes what? 18 Newton. Now let's check on the questions B. What is the volume of the block in SI unit? What is the volume of the block in SI unit? So you remember, when you're determining the measurement, should be in meters what? Cubic, because it is a volume. So what you do, class, I'll encourage learners to be able to change from this level. I'll encourage learners to be able to change from this level. It becomes so easier compared to multiplying than converting. Most of the learners end up forgetting. So we start converting here direct. We know very well 1 meter is equivalent to what? To 100 what? Centimeters. So what about what? 15 centimeters. So we take 15 centimeters, we multiply by 1 meter, we divide by what? Centimeters cancel the centimeters, which is going to give us what? It's 2 decimal places, 0.15. So having here it is 0.15 centimeter. Now 6 centimeters itakuwa ngapi class? 6 centimeters itakuwa nini? 0.06. Now 4 centimeters itakuwa nini? 0.04. These are meters. Remember, you are determining the what? We are determining the what, class? We are determining the volume. So when you are determining the volume, where's the duster? When you are determining the volume, where's the duster? When you are determining the volume, class, volume is equal to what, class? Length times width times height. Now let's check on our length. Our length is what? Our length is what, class? 0.15 meters. Multiply by our width is what? 0.06. And our height is what? 0.04. So put in a calculator and give me the answer. Hurry up, hurry up. Shuremi, hurry up. Have you multiplied? The answer? 0.0? 0.0? 0? 0.0? Another 0. Then 36. Like that. So this one becomes what? Meters what? Meters what? Meters cubic, because we are determining the what? The volume. So let's check on the question C. The greatest pressure that the block exerts on the surface. The greatest pressure. We say when you're having this block, you have two surfaces. You have the lower surfaces and the sideways surface. You have the lower surface and the sideways surface. And they're talking about the greatest surface, pressure. Between the lower surface and the sideways surface, which one has what? The greatest pressure? Between this pressure that is going to apply here and the pressure that is going to apply on the width side. The pressure that is going to apply on the lower side and the pressure that is going to apply on the width side. Which one will have the greatest pressure, class? The width side. The width side. So when you're determining this pressure on this box, remember here you have 0.0. Remember you have 0.0, 0.15, 0.15. Remember the width side we have what? 0.06, 0.06, and the height is what? 0.04. So these are now the units that they're determining. From this box, we have this measurement. We have this measurement of 0.6, and we have the height of the thickness of what? 0.04. So when they're determining the pressure, this side becomes the greatest side because the surface of it is small. And we said when the surface is small, the pressure will be high, isn't it? So when they're determining about it, remember we are talking about the area. You look on the area of that surface. Look on the area of that surface. Meaning, when you're determining pressure, greatest pressure will be, you take the what? You take the force over the area. And this area should be in what? The area should be in meter square. The force should be in what? In Newton. Area in meters square and the force in Newton. Already the force, you already got therefore our force here. This force is going to be applied on the both greatest pressure and least pressure. Now let's come and check on the area of this one. Let's look on the area. This side comprises of the measurement of what? 0.6, and the height comprises of what? 0.4. So it shall take 0.06, we multiply by 0.04 as the area. What are you going to get, class? Multiply so fast. So you have 4 times 6 is what? 20? 24. Decimal place is 1, 2, 3, 4. So this one becomes meters what? Meter square. So you shall be able to take this meter square. Pressure of the greatest is force over area, which is in Newton, and the meter square. Already you have in meter square and already you have our force as 18. So we shall take 18 Newton over what? 0.0024 meter square. What do you get, class? What do you get? 7,000. Eh? 7,500. So this one becomes what? Newton per. Remember the units. Newton per meter square. Now let's check on the last one, the least pressure. We say the least pressure will be able to comprise with the large surface. So on our large surface is this, the lower surface, that as the surface of it is large compared to the sideways surface. Now, when you are going to put on it, you can see it is relying on the lower side, which will have what? Let's look on the area of it, class. Remember the pressure of it will be Newton over meters square. Remember again, least pressure will be Newton over the meter square. But whatever is going to be determined the meter square here is the area of it. Now, let's look for the area. It's length times width. Our length will be what, class? Our length will be what, class? Length itakuwa nini? 0.15 meter square, and the side of the width we shall use what? 0.06 meters. Use your calculator so fast. Use your calculator. What do you get? 0.009. That's the meter. Let's go back to the formula. pressure is equal to Newton over meter square. Our meter square is 0.009 meters square. So we come in and determine. Our force is what? Our force is what? Our force is 18. We take 18, 0.09. These are Newton. These are meter square. So now dividing, what do you get? 2,000. So class, you can compare. You can compare this. You can compare now the surface, the two surfaces. The less surface, which are the highest, the surface of it is greater. The larger surface, you can see the larger surface as which pressure? As which pressure class? 2,000. And the one that has little surface, you can see, has which pressure class? 2,000, 7,500. And that's what we are determining now. The pressure will be determined by the surface. When the surface is less, the pressure is high. And when the surface is large, the pressure is low. Thank you.